In the last movie, you learned about merging 3ds Max models built in different scales between one scene and another. The problems encountered were few and mostly related to a quick reset of real-world mapping scale. In this movie, you simulate the same problem using FBX files. You will learn that you may encounter additional problems in the process. Most 3D applications today can export to the FBX file format. 3ds Max, in turn, can import or even link FBX files coming from other applications. The trick is to know how to handle scale differences between these external applications and 3ds Max. It helps to know how external applications export FBX files. If you're in architecture, for example, and use Autodesk Revit, you may find it interesting to know that Revit always exports in feet. This means it doesn't matter how you set up your Revit project, the resulting FBX file will always be exported in feet-based units. This happens even when you opt to use a metric template at startup. Here, I'll keep the model very simple, using a U-shaped wall that has a brick finish. I'll also limit the wall heights to go from level 1 to level 2, which is set to 4 meters high by default. I'll also insert a standard door to study its behavior as well. This is enough for now. I'll export this simple scene to an FBX file. Open or reset 3ds Max and set the system units to inches, which is the default setup. Leave the display units to feet and inches for now. When you try and import the FBX file named walls.fbx you just saw me create in Revit, you'll notice that the incoming file units are indeed in feet, even though you saw me set the Revit scene to metric. So, the incoming file is based in feet, and the current scene is based in inches. In the Advanced Options rollout under Units, you will notice that a scale factor is needed to make the Revit models behave properly. The scale factor is set to 12 in this case, as there are 12 inches to a foot. Click OK and dismiss the warning about the camera offsets. The imported models appear, and they seem fine at first glance. Open the Slate Material Editor and sample the material from the walls. Submaterial number 1 is the one that defines the brick layout. Select it and make sure it is set to show in the viewport. Dismiss the Material Editor for now. The brick size seems to be working properly as well, so for all intent and purposes, you could leave well enough alone. However, if you decide to make changes, you need to learn to overcome a few issues. First, notice what happens when you pick the Scale tool and you select Objects. The scale factor on each and every imported object is set to 1200 instead of the default 100. This is because of the scale factor value of 12 you noticed earlier in the FBX import dialog. Again, if your purpose is just to render the scene as is, then you don't need to do anything. But if you want to bring changes to the geometry or the materials, then you need to work on the models. Here's an example of potential problems that can occur. Let's say you decide to replace the Revit door with a 3ds Max animatable door. This is a standard 3 feet wide by 7 feet high door, so you can go ahead and create a similar one in the scene. Now select the Revit door and apply a substitute modifier to it, and pick the 3ds Max door as a replacement object. Well, this certainly doesn't look right. You now end up with a door that's 12 times bigger than it needs to be. Delete the substitute modifier. You'll come back to it in a moment. the problem occurred because the transform matrix is different between one door and the other. The scale factors are different. To fix the problem, the scale factor on the Revit door should be set to 100% as well. Of course, if you scale the Revit door down from 1200% to 100%, it becomes too small for this scene. You would then need to scale it back up 12 times at the sub-object level, so that the overall object scale remains at 100%. This can be achieved using the X-form modifier. Add an X-form modifier and access its gizmo level. Right-click the Scale tool and set the gizmo scale to 1200%. The door is back to its proper size. Exit Gizmo mode and notice that the object scale is still at 100%. Try the Substitute modifier again. Other than a slight relocation of the door because of differing pivot points, the scale factor is not an issue anymore. This FBX scaling at import time, affecting global model scale, can also have an impact on texturing. Let's say you want to use a different brick texture for the walls. Go back to the material editor and create a new standard material. For a diffuse color, use the provided brick red JPEG image. As mentioned in the previous movie, this particular brick layout is 40 inches by 40 inches in size in the real world. Set it accordingly using real-world scale, as all Revit models use this mapping technique. Make sure the new material is set to show in the viewport and apply it to one of the walls. Well, this certainly doesn't look right, as the bricks now seem 12 times bigger than they should be. Select the wall with the new material and add a UVW map in box mode and set it to use real-world map size. This doesn't seem to make a difference. Again, this is due to the fact that the wall's transform matrix is compromised. Delete the UVW map modifier. Instead of manually fixing the scale the way you did with the door earlier, there is a utility that will make this task much easier. Verify that the scale of the wall is indeed set to 1200 and then go to the Utility panel. Choose Reset X-Form and then click the Reset Selected button. Visually, nothing happens, but a closer look will show you that the object scale now is set to 100%. This tool automates the manual steps you did earlier. This means that adding a UVW map modifier now fixes the brick size problem. You may have noticed in passing the X-form modifier that the utility added to the modifier stack. Even if you are not planning to change the materials, it is good practice to use Reset X-form on all imported objects to reset their scale. The fact that you can use this utility on multiple selected objects make it quite useful. I will conclude this movie by saying this. When working on architectural projects, I always set my system units to feet. It works well to define the overall scope of most architectural projects. It also makes it easier to handle Revit models if and when I need to import or link them to 3ds Max. When the transfer between the two applications is one-to-one, you wouldn't need to worry about resetting X-forms or mapping coordinates. If I were to open this file I used earlier, and which I already set to system units in feet, and then decide to import a Revit model into it, such as a detached garage similar to the one we worked on earlier, you will note that the two files have the same base scale, feet, and that the scale factor conversion is set to 1.0. Because the incoming FBX file and the current scene are set with the same base unit in feet, this means that all objects come in with a 100% scale factors and no resetting of the transform matrix is needed. This also means that any materials you have already designed in 3ds Max would work flawlessly on Revit imported models. While setting your system units to feet obviously makes your work a lot easier, You can still set your display units to any option you favor. This concludes this tutorial on system units, transform matrix, and reset X forms. I hope it helps you understand some of the discrepancies that take place when sharing models between scenes and between 3D applications. I'll be back soon with more tutorials and workflows.